Grab your caffeinated beverage of choice and put on your favorite programming playlist, because in the next hour and a half, I'm going to show you how to code this 3D art gallery from scratch. Along the way, I'm going to be teaching you the fundamentals of Three.js, which is a powerful library for creating 3D web applications and games. When you're done with this course, you'll have the knowledge needed to start building your own 3D web experiences right in the browser. And don't worry, if you don't have any experience with 3D or with Three.js at all, this course is for you. This course is designed with beginners in mind, so I'll be explaining all the different concepts behind 3D and Three.js along the way. Now, if you find this course helpful, I encourage you to check out my Patreon and think about becoming a member. You'll get early access to videos, voting rights on future topics, even access to a private Discord server where I can give you one-on-one feedback and help. And if you're not ready to become a member today, that's totally fine. I still encourage you to become a subscriber of this channel so you can get notified of future courses that I'm putting out. Now, if you have absolutely no idea what Three.js is, I think it's better that I show you what you can do with Three.js rather than telling you what it is. So here's a few quick examples of some really cool applications made with Three.js. So let's get started by getting a simple Three.js project up and running. So right now I am on the Three.js website, which is three.js.org. And there are a bunch of really cool demo apps on the front page, which I encourage you to check out. But we're going to be diving into the documentation on the sidebar here. Now there's a lot of different articles to read. We're only concerned with this one called installation and this one called creating a scene. So starting with installation, obviously we're going to need to install the Three.js library. That'll be the first thing that we do. And they also recommend installing a build tool, so installing Three.js with npm. Now, if you're not familiar with what npm is or what a build tool is, I would encourage you to go check out a couple tutorials on what exactly these are and how to use them. That's kind of out of scope for this tutorial. So I'm going to assume you have some knowledge of npm. So how to install packages and things like that. Now we're going to go with this option 1 here. We're going to install with npm and a build tool, and that build tool is Vite. So they give you the instructions for how to use that here. So we'll be installing the Three.js library here and then installing Vite as well. So let's just copy and paste both of these. Now I already have a VS Code project set up, so really that's just a folder, and I've opened that folder in VS Code. So I'm going to have my terminal up and running as well, which you can open up with Control-tilde on Mac. And then I'm going to paste these commands in here, and I'm going to run these. So you can see it did a few things. It created a package.json file here, and it created this folder called node modules, which contains all of our dependencies. So let's go into this package.json folder. Let me expand this a bit. So we have our Three.js dependency, we have our Vite dependency, which is a dev dependency because that does not get bundled with our application. And then let's go ahead and add a new section here called scripts. And then we're going to add a script called dev. And all this script dev is going to do is going to run this command Vite. And that's going to basically kick off our build tool. It's going to put it into dev mode. It's going to build our application and then serve it locally so we can go and visit our website. Now, we don't have any website yet. We don't have any JavaScript, HTML, or anything, so we need to go ahead and create that. So let's go back to our Three.js documentation, and let's click on creating a scene. Now, they do a really good job of walking you through what all the parts in the scene are doing. I'm not going to walk through this article, but I am going to talk through these different lines of code that we'll be copying over in just a minute. So don't worry if it feels like I'm rushing ahead. I'm going to scroll to the very bottom here where they have the completed simple Three.js program that we can just copy it. So I'm going to copy this index.html file. So I'll right click and create a new file called index.html, and we'll paste that in. And right away I'm just going to go ahead and rename this 3D art gallery. And then let's also go ahead and create a file called main.js. You can see that we are importing that script as a module in the body of our HTML doc. And I'm going to go back to my browser here, and I'm going to copy all of this code and paste it in my main file. Now, pulling the terminal back up here, remember that we added a script called dev. So all we have to do is npm run dev. And you can see that runs the Vite command, and now it is serving our website at this address here. So all I need to do is command click on this on Mac. And there we go. We have a spinning green cube, which is the demo Three.js app. We have this up and running. That's really cool, but we have no idea how we got here. So let's rewind a bit and see what's going on. So I'm going to leave this running, and I'm just going to close this terminal so we have a bit more room to work with here. And let's go and inspect this main.js file. So what is all happening in here? And I'm going to rearrange this slightly. Put these lines down here. So first thing, we are importing our Three.js library, and we're importing the whole thing, and we are importing it as this alias 3 in all capital letters. So any part of the Three.js API that we want to access, we'll always do 3 dot, and then we have access to all the classes and everything that comes with Three.js. So the first thing that we're doing is we're setting up our renderer. So under the hood, Three.js is using WebGL, which is the API built into browsers for rendering 3D graphics, also 2D graphics. So we're creating a new instance of the WebGL renderer. Now the renderer is responsible for taking all of our 3D stuff and then rendering it onto our screen, which is obviously 2D. So there's some kind of complicated math and stuff going on under the hood where it figures out how to take all that 3D information and render it in basically a 2D rectangle that we can look at. So the first thing we need to do is to tell our renderer, how big is that rectangle on the screen. So we're setting the render area to the size of the window. The next thing that we're doing is setting the animation loop for our renderer, and we're setting that to the animate function. Each frame that our renderer is rendering, it's going to be calling this function here. Now I'm going to talk a bit more about what is happening here in just a minute, so let's skip over that for now. So we've set the size, the animation loop, and now we need to add the DOM element or HTML element associated with our renderer to our actual HTML document. And what is that exactly? So I'm going to open up the developer tools, and let's make this a little bit bigger so we can read it. Right here, you can see that there is a canvas that was added by Three.js. So it has the width of our window, the height of the window, and then some other information here. But that DOM element is that canvas. That's what is being added. Now that we have our renderer all set up, the next step is defining our 3D scene. So we start by creating a scene object. That's always really the first thing that you do. And a scene is where we place our objects, our lights, and our cameras. So one thing that's worth noting is the scene is a hierarchy. So it's you can think of it as a tree where the scene is sort of the top level parent, and beneath that we can have different objects. And an object can be a child of another object, and you can just create as many layers as you'd like to. Now there's a lot of benefits to doing that, and we'll talk about that a little bit later when we start creating our gallery. We're going to be setting up some parent-child relationships, and I'll explain why we're doing that. Before we get to that, we need to set up a camera. So this is basically what we're looking through in order to see our 3D scene. So you can think of a camera as a pair of eyeballs, and we're telling Three.js, how are those eyeballs configured? Like, how widely can they see? Are they like a deer where you can see like 180 degrees field of view, or is it more kind of like a narrow focus? What's the closest thing that we can see? What's the furthest thing away that we can see? So we're configuring all of that here. Now we're using a perspective camera, and that's how we see, since we have two eyes. If we stare at a horizon, things sort of vanish as they go towards the horizon. That's what we're replicating here. And then these different parameters that we're passing in, the first being field of view, that controls how much we can see, basically the angle of the view. The next one is the aspect ratio, so that's just the width of the window divided by the height. And then what's the closest object we can see, so 0.1 units away, and then the furthest thing that we can see, we set that to 1,000 units. So basically just really, really far away. The camera is one of the essential things that we need in order to convert the 3D scene into a 2D representation on the screen. So a lot of the math is baked into this camera here. So you may have noticed we don't have any lighting yet, and you actually don't need lights. You can just tell Three.js, I just want to render some colors. I don't care, how it's lit. So we're going to start off with that. We're not going to have any lighting. We'll add that in later. Now, anytime we need to add a 3D object, there's 3 different things that we need to add. And those are the geometry, the material, and then finally the mesh, which combines the geometry and material into a single object. Now, what is geometry? So WebGL treats everything under the hood as triangles, and that's because graphics cards are really good and really fast at rendering triangles. So this box geometry is basically a collection of all the points on the box, so all the corners, and then it's connecting those points together in a series of triangles. So each face of our box is 2 triangles. So ultimately, it's adding, I think that'd be 12 triangles for the box. 6 sides times 2 triangles each side is 12 triangles. So this is a collection of the 8 vertices of the cube and the 12 triangles that make up the sides of the cube. Next, we need to know how to fill in those triangles, and that's what the material is for. So the mesh basic material, there's a whole bunch of different materials. We'll be looking at some more advanced ones shortly. The mesh basic material is an unlit material, so we don't need any lighting. We don't need any lights in the scene to tell us, what color this is going to be, how light or dark it's going to be. We're just giving it a color. And that's why when we look at this cube, we don't see any shading on the sides. It's all just one uniform color, which makes it kind of hard to determine, if it's actually 3D or not. So lighting and shading is what gives that 3D effect. So don't worry, we'll be adding that in shortly. So we define our structure of our 3D object with geometry. We define how that object looks with the material. And then we combine that together in a mesh. And then finally, we take that mesh and then we add it to our scene. Now, one more thing we're doing here, I'm just setting up the position of the camera to be 5 units away from the origin. Our cube right now is sitting at the origin. So if I were to make our camera set the Z position to 3, our cube is going to look a little bit bigger. And if I were to move our Z position to, say, 10, then we'd expect the cube to be smaller. So by moving the camera around the scene, that's going to give us a different perspective on the 3D scene. Now finally, let's talk about this animate loop here. Now a real-time 3D application like this, really what is happening is there's a bunch of still pictures that are being created and they're being displayed to you really, really fast so it looks like a movie. Now my monitor is, I think, 120 hertz, so Three.js is going to attempt to render the scene 120 times per second. And it's going to be calling this animate function because we pass it in and set animation loop. It's going to be calling this function 120 times per second if possible. If we have a lot of complex stuff going on, then it might not be able to keep up that 120 frames per second. And if you've played any games, you notice when you have lags and stutters and things like that, it's because it just can't call this animate function fast enough. There's too much going on. But our scene's really simple, so that's not an issue. Now, in order to add a little pizzazz, we did some rotation here. So we can rotate the cube around any of its axes. So if you're not familiar with any 3D math, that's okay. This is all very intuitive. The 3D world is broken down into what's called 3 axes. And those are labeled X, Y, and Z. So you can think of X as like the left and right direction. Z is forward and back, and Y is up and down. So if you just think of those directions with respect to your body, that helps put an image as to what these labels mean. So we are rotating the cube around that x-axis. So if you did like a flip or like a back flip, that would be that kind of rotation. And we're rotating it around its y-axis. So if I was just to spin in a circle, stand up and spin in a circle, that's what that would be. So we're rotating it each frame by 0.01 radians Radians is just an angle measurement, just like degrees, just a little bit different. So we're doing that each frame, and then we are rendering our 3D scene from the perspective of our camera. So we're telling our renderer, render this scene using this camera. So we could have different cameras, we could have different scenes, and the renderer can render those, at will based on what we pass in here. And that gives the effect that we have on the screen. So I know that was kind of a drawn-out explanation, but really this is the core of any Three.js application. So if you can really understand what's going on here, then it's going to set you up really well for all of the content coming forward. So now that we've talked through this basic demo example, I think it's time to make it a bit more interesting. So let's start working towards our 3D art gallery and just start adding layers of complexity on slowly so we don't get too overwhelmed. Now, before we jump into any more Three.js code, there's a little bit of extra setup that we need to do in order to get our project ready for our 3D art gallery. Now, I've gone ahead and added some images to a public folder. So public is at the root directory here, or at the root level of my project, I mean. So I've gone ahead and added these different images of the artwork that I wanted to add in. And I also added some arrows here, which I'm going to use for the buttons to scroll through the art gallery. So I've just gone ahead and added these assets to my project. And additionally, I've defined some constants at the top of my main.js file. I've defined 3 different arrays here. So the first array is the array of image names. So these are just the names of the images in my public directory. You can see I've left out public in the path. That's just assumed. And I have an array of the titles of the artwork. So these all correspond to each other. So you can see this first image is The Death of Socrates. And I'm not even trying to pronounce this. My French pronunciation is quite bad. This is the artist for that painting. And the next one is Starry Night by Vincent van Gogh, and so forth. So later on, once we are populating all of our images and we're displaying the titles and the artist for the piece of artwork, we'll be utilizing these arrays. But I just wanted to get these added right away before we go any further. Now, one thing that you may have noticed is that when we are resizing our screen, our 3D canvas is not resizing as well. So let's go ahead and fix that right now. That's an easy fix. So back in our main.js file, underneath our animate function, let's add a event listener to our window. And I want to listen to the resize event. So anytime that window is resized, it's going to call this function here. So we pass in a function handler here. And there's a few things that we need to do. And first is we need to update the size of our renderer again. So we'll do renderer set size. And then we'll just copy this line here actually and paste it in there. So let's see what effect that has. And note that since Vite is running in the background, anytime we make changes, it's automatically rebuilding and redeploying the app. So we don't need to do anything additional. It's really nice to work with. So now I'm resizing the screen. We can see that our scene is resizing, but it's squishing the object. And that is because the camera still thinks our screen is really big. So we need to update our camera as well. So we'll do camera aspect, and then we will set this to the window width divided by the window height. And then we need to go ahead and call update projection matrix on our camera. We don't need to know what the projection matrix is. Just know that we need to update that anytime you update the camera aspect ratio. So now if we go back to our Three.js app and I shrink the window, I make it wider, our cube stays the same size without squishing. So that is a really quick fix for handling window resizing, and you should add that in all of your Three.js projects going forward. So now we're ready to finally start building out our 3D art gallery. So in order to illustrate this, I'm going to draw a little picture on the screen. So as you recall that each 3D object we need to add to the scene needs geometry, it needs material, and then we combine those together into a mesh. So I'm going to have 6 paintings. So I'm going to need 6 different meshes. And I'm going to position them in a circle, kind of like this. So I'll have ones here and here, and then ones here and here, and just forgive my horrible art skills, and 2 more paintings here and here. So we're creating sort of a hexagon. And then next to each piece of artwork, we're going to have some left and right buttons. So those are going to go just to the left and right of the paintings. It's a little hard to illustrate, but there we are. And if I were to look at like a front-on view, we're going to have our canvas here with the artwork on it, and then we'll have a left arrow and a right arrow. So how do we set up our scene hierarchy to draw all this? Now our base element here is our artwork. So that is going to be a mesh of a box. It's going to be a really flat box. So it's going to have, a height in this direction, a width in this direction, and then the depth is going to be a really, really small amount. So it basically looks like a piece of paper. And then the left and right arrows are going to be meshes as well. It may not look like it, but they are. Those are also going to be boxes. And then we're going to put, that left arrow on there, and we're going to have another one over here with a right arrow on there, and we'll just make everything behind the arrow transparent. So it doesn't look like a box, it looks like an arrow. But if we click anywhere on this box here, then we're gonna basically detect that click and then trigger that rotation. So these are 3 different meshes that we're gonna have, and we want these all to rotate together. So when we're setting up our scene, we're setting up that parent-child relationship with all these objects. What's important to remember is that when you have one object that's a child of another object, it's going to inherit that parent's transform. Now, what is a transform? A transform is a fancy representation of the position of an object in 3D space. So the X, Y, Z coordinates of where that object is, and the rotation. So remember we did the rotation of the cube. So how much that object rotates around each of the X, Y, and Z axes. And then scale. We can shrink the object in each axis, so we can, squish it forward and back, squish it left to right, squish it up and down. Now, when I'm rotating the art gallery around, I want all of these things to move together. If I were to just, rotate them each individually, they're all going to rotate around their own axes, and that's not going to be the look that we want to go for. So what we need to do is we need to add all these as children under a parent object. So this arrow is going to be a child of this object here. So is our artwork, our canvas, and so was this. And then as we rotate this parent object around, all of these objects are going to rotate together, not independently. And then we also want our paintings to be distance away from the camera. So we're going to create actually another, and this will be the root node of our entire scene. This will be parented to that node. So we have 3 different levels here. So what all this does for us is that when we are rotating our art gallery around, all we have to do is rotate this root node around its own y-axis. And remember, that's kind of like, if I'm rotating in my chair like this, then all of the artwork is going to rotate with it because, each of our pictures with its left and right buttons is parented to this red node here. And we have 6 of these. Remember, we have our hexagon arrangement. So each of these is going to have its own, let's call it like a base node or a parent node. And then we're going to have all those sort of be distance away from our center root node. So that's what we're going to be doing to set up our scene. I know it's definitely going to be a little bit tricky if you're just coming into 3D for the first time, but 3D definitely stretches the brain a bit. I often have a hard time working on it when I haven't had enough coffee. If you're kind of lost right now, don't worry about it. Just, this is something that you can work on later as you do more and more 3.js projects. It'll become easier as you go, I promise. Now, let's go and turn this into some code. So I'm going to erase all of this and close that. And let's go back to where we are defining our cube, and I'm just going to delete all this code here. And let's not forget to delete where we're rotating the cube as well. So when we're done, we should have just a blank canvas. So let's start with adding just one piece of artwork, and then we'll add the other 5 pieces of artwork in using a for loop later on. So first, let's create a new mesh. And I'm just going to pass the geometry and material right in here. I'm not going to create separate variables. So the first argument is the geometry. So I'm going to do a new 3 box geometry. Now I want my artwork to be a little bit wider than it is high. So I'm going to do a width of 3 and then a height of 2. And then the depth is going to be something really small, like 0.1. And then as far as the width segments go and height segments, we don't need to worry about those. We'll leave those as the default of 1. And then we need a material. So before we go ahead and apply the images of our artwork to the box that we're creating, we're just going to set it to some arbitrary color. So once again, we'll do mesh basic material. And then it takes in a parameters object. So there's lots of properties that we can pass in the material. Many of these you'll learn over time as you use Three.js more and more. But for now, we're just using color. And let's set that to, let's do like a shade of red. So do kind of a light red here. And then we'll go ahead and add this artwork. Or sorry, we need to add it to the scene. Scene, add artwork. Now, if we go and look at our canvas, we're not seeing anything here. So let's go and determine why. Now, our camera we have placed right at the origin, and we haven't given our artwork any position. So we set the position of the mesh itself, not the geometry. So right now our artwork's right on top of the camera, so we need to push it back again a bit. So we'll do artwork, position, and then remember the z-axis is forward and backwards. And by setting this to, let's say like a -4, that is going to put it in front of the camera. So there we go. There is our artwork, our little box that we created. Now, if you remember our artwork, we'll just draw a quick picture of that again, our rectangle for our artwork. We're going to add some left and right arrows on either side of it. And then these nodes, these meshes, are going to be children of a base node that's going to sit at the origin. So all of these nodes will be positioned relative to this base node. And then for each piece of artwork, we're going to have 6 pieces of artwork, each spaced out 60 degrees, because we have 6 pieces of art. So 360 divided by 6 is 60 degrees separation. And that'll give us that hexagonal formation of art. So we need to add this base node here. And then we need to parent our artwork to that node. And I'll show you how to do that now. So let's go ahead and add a base node. And this is actually going to be in Object 3D. So in Object 3D, it has no geometry, no material. It just represents really a point in space. That's a good way to think about it. And you can attach other meshes and other objects and other groups to this node. So first of all, we need to add this node to the scene. And then now we want our artwork mesh to be a child of this base node. So instead of doing scene add artwork, we're going to do base node add artwork. So the artwork, we're offsetting it in the z direction by -4 relative to the base node. And then the base node is just right at the origin. The result of that is it looks exactly the same, which is what we would expect. But it's going to make a difference later on, because we're going to be rotating these base nodes based on which piece of art that we're instantiating. So finally, we need to add that root node. That's going to be another Object 3D. And then all of our base nodes are going to be added to this root node. And then we want to add the root node to the scene. So this will make a little bit more sense once we add the extra pieces of art in. So let's do that now. So we're going to have a count of 6 pieces of artwork, and then we're going to do a for loop here. So we'll put all of this in here. So we're going to have 6 base nodes and 6 artwork meshes. And let's see, I want this to be less than count. Use our variable. So let's go look here once again, and it still looks exactly the same. And that's because all of the artwork right now is sitting right on top of each other. So what we need to do is we need to space out these base nodes. So if I were to draw out a circle, it's going to be arranging our artwork in a circle. We're going to have one here, one there, one there, there, and there. And all of their base nodes are going to sit here. But they're all going to be offset a little bit. So this is going to be a bit like a pizza pie cut into 6 slices. Now we know that there's 360 degrees in a circle. So what is this angle right here? We can figure that out by dividing this by 6, and that equals 60 degrees. Now to complicate things a bit further, when we're working with 3D mathematics, things like that, trigonometry, we don't use degrees typically. We use something called radians. Now, instead of having 360 degrees in a circle, we have 2 pi radians. If you remember from your high school math class, pi is equal to 3.14 ... So quite a few extra digits there, but these are just the main ones. So 2 times 3.14, we'll multiply that by 2. So there's 6.28 radians in a circle. And we could convert that back and forth between radians and degrees. But it's helpful to think of this as 2 pi. So we need to, instead of dividing 360 by 6, we'll divide 2 pi by 6. And if this is making your brain explode with math, don't worry about it. The math can always come later. So for each of our base nodes, remember that the y-axis goes up and down. So if we want to rotate around that, that up and down axis like this, then we're going to set the y rotation of these nodes. So we're going to do 2 times math.pi. And then we're going to divide that by count. And then we'll multiply this whole thing by I. So you can think of this as doing 360 degrees divided by count, but the rotation is expected in radians here. So we just replace 360 with 2 times pi. So that'll give us pi over 3 radians. And then as we multiply that by the index here, that'll basically be 60 degrees, 120 degrees, 180, 240, 300, 360. So now if we go and look, we can see that we have artwork on either side now, but we can't see what's behind us. So let's make this a little bit easier. So for our root node, just like we were rotating the cubes before, let's update the y rotation. So we'll just add, let's do 0.05 every frame. And that is way too fast. Holy cow, that is terrifying. We'll do 0.01. So still a little disorienting, but now we can see that as we're rotating that root node, we have all the pieces of artwork are slowly rotating in a circle. All right, so I slowed it down a little bit. So we have all of our artwork, all the meshes for our artwork displayed on the screen. They're all positioned correctly where we want them, so we can have kind of that rotating carousel. But it's pretty boring. We don't have any actual art showing yet. So I'm going to show you how to do that next. And that's a technique called texturing. So what we can do is rather than specifying a color, we can specify an image that we want to apply to that mesh. So let's go ahead and do that. Now, first thing, when we are loading images, or as we call them in Three.js land, textures, we need to create a texture loader. So let's say right before my renderer here, I'm going to create a texture loader variable, and that will be a new 3 texture loader. So we create that there. We just create that one time and reuse it. And then we want to load the artwork in our for loop here. So let's say our texture is equal to texture loader load. Now we need to specify the URL of our images. And remember back, we created these arrays right when we started out. So we need to get the file name of the artwork that we want to load for this particular index. So all we have to do for that is do images and then pass in I as the array index. So this is a 3.texture, so this has all the image data along with a bunch of other metadata that we don't have to worry about right now. Now, how do we apply this to our mesh? It's actually quite simple. So let's erase the color here, and instead let's specify the map. Now, the map is just a fancy name for texture. You can see we pass in a type of texture here. So all we do is specify texture. And then if we go back, we can now see that all of our images are loaded. But they do look a little washed out. So there's one thing that we have to tweak here. So on our texture, we need to set the color space to sRGB color space. I'm not going to get into explaining what color spaces are in depth. Really, it's just how do we display certain colors on the monitor. And there's a definite benefit to using sRGB behind the scenes. This was a fairly recent change made in the last year that you need to specify this, but you don't need to know all the math and theory behind the color spaces. Just know that when you're loading textures, if they look a bit washed out, make sure you're setting the color space of your texture right after you load it to sRGB color space. So now if we go back, we can see we have nice, rich, beautiful colors on all of our artwork, and they're looking really good. Now I think one other thing that would help add a little bit of polish to this is adding a border around our images. So we can do that pretty easily by just adding another mesh that kind of sits behind the picture and is just a little bit wider and a little bit taller than the picture. So right before we define our artwork, let's add another mesh. We're going to call that, let's see, I'll call it border. And then we're just going to add that to the base node. This is basically going to be the same geometry. And for the material, I'm going to do a flat color. So let's do color, and let's make this kind of a really dark gray. And if you don't know how to do hex colors in your head, there's a lot of good websites out there that'll allow you to basically pick from a color wheel or a color palette, and it'll output the hexadecimal value of that color. So I highly recommend finding one of those tools if you don't have these kind of things memorized yet. Now we want the border to sit behind our artwork a little bit. So really how I'm going to do that is just I'm going to make it a little bit skinnier. So it'll be 0.9. Then I'm going to make it a little bit taller and a little bit wider. And that might be too dark to see, so let me change that to be a little bit brighter. So I got to make sure I add it as well. Oh, I forgot to set the position on that. So that's probably the issue there. We want this position right at the same position as our artwork. So there, now we have a little black border around our images, just adds a little bit more polish there. Now this is looking pretty good, but one issue is that everything's uniformly lit. There's not a lot of kind of dynamics in this. It'd be nice if we could fade out the images on the left or right of the center image, and then just kind of have a spotlight shining on that center image to really highlight it and make it stand out. Let's go ahead and add some lighting, because right now we're not doing any lighting. We're using these mesh basic materials that are unlit materials. So after we add our artwork here, right after this for loop, let's go ahead and create a new variable called spotlight. And this is going to be a new 3 spotlight. Now there's other types of lights, which I'm not going to get into. But I'll briefly mention them. There's ambient light. That allows you to light everything in the scene uniformly, except you can control the color and intensity of that light. And there's a directional light, which acts like a sun. So it's as if the light source were infinitely far away, and it's all shining in one direction. There's also a point light, which you can think of as like a light bulb in a dark basement. But we're going to be using a spotlight. So for our spotlight's color, I'm going to set that to white. And for the intensity, I've played around with these values before. Let's set that to 100. The distance is the maximum range of the light. So let's set that to, let's just say 10 for good measure. For the angle of the light, We'll have to tweak this number a bit, but from experimentation, I found that between 0.6 and 0.7 works pretty well. Now, penumbra, one's a bit interesting. I'm going to set this to 0 for now. And there's also decay, which lets you control how the light dims over the distance of it. We're not going to set that. We're just leaving that at the default value. Now let's go ahead and add our light to the scene. And if you pay attention closely, you can see that everything looks exactly the same. And that is because we're using mesh basic materials, which are unlit materials. So we need to change these to standard materials, which are a little more powerful, and they allow you to render an object using lighting. So now if I change our border and our artwork to these standard materials, we just get blackness. And this means that our light isn't configured correctly. We haven't done something right. So with a spotlight, you can think of that spotlight needing to have both a position and also knowing where to look. So let's begin by setting the position of that light. So we can just do position.set. This will allow us to set the X and Y and Z position of that light. So I want that light at the origin, and I want it kind of right above the camera. So I'm going to set it to 0 in the X and Z, and I'm going to move it 5 units up in the vertical direction. Now we also need to tell that light where to look at, so we'll do spotlight, and we can control where it looks by setting the target. So target position set. So target is in object 3D, so that object 3D has a position. Then we'll set it to 0, 1, and then we want it to kind of point towards the artwork. And then another caveat here, if we look at the documentation for the spotlight target, for the target's position to be changed to anything other than the default, it must be added to the scene using scene add light.target. So we need to also add the spotlight target to the scene. Now let's go see what we have. So now that we can see our artwork is lit once more, but I want to have a little bit more fading around the edges. So let's go and control that. So we can do that by setting the penumbra here. So if we read the documentation here, the percent of the spotlight cone that is attenuated or reduced due to the penumbra. So around the edges of the cone, if we set this to a higher value, it's going to cause the light to kind of fade out around the circumference of that cone. So if I set this to 1, I think I need to expand this out a bit. Now you can see that on the left and the right edges of our screen here, the artwork is just kind of fading out, which gives a really cool effect and allows the focus to be maintained in the center of our screen. Now I can go and let's say I want to reduce the angle of our spotlight to 0.5. That's going to reduce the size of that cone. And you can kind of see that circle of the cone, the light cone. And maybe we need to point it down a little bit. So let's set the target position to maybe 0.5 instead of 1. Here the cone's centered a little bit more on the image. But this is fading things out a little bit too much. When our artwork is right in the middle of the screen, we can't see the artwork on either side. We want to tease it a little bit. So I'm going to set that back to 6.5. And just to show you, I'm going to set the penumbra to 0.5. And you can see that doesn't fade out quite as much on the edges of that cone. And if I were to set this to, let's do 0.5 again and 0, you can see that's a really hard cutoff. It's very harsh, doesn't look very good. So we want to set that penumbra to a higher value. Give it a nice gradual fade out. So that's it. That's all that we needed to add lighting to our scene. That gives kind of a nice variation as the images are coming in and out of view. Now there's one more thing that we can do to really step up the visuals in our art gallery, and that's adding reflections. So luckily with Three.js there comes a class that can help us out with that. So let's go ahead and add that now. Now at the top of our file here, let's do import, and then I can start typing reflector, and you can see auto-completes right here. So we'll choose that. Now below our spotlight here, let's create a new variable called mirror. And this is going to be a new instance of reflector. Now this takes in a geometry. And all we're going to pass in for that is a new circle geometry. So the radius, we'll do something large like, let's do like 12. Maybe 10 should be good enough. And the number of segments, we can do, let's see, 32 is the default for that, so that should be fine. Now for the options here, we need to pass in a color, the width of the texture, and the height of the texture. You can think of this as another canvas that we're rendering to. But rather than rendering to some rectangle on the screen that the user looks at, we're going to be rendering to this ground plane that sits beneath our artwork. And that ground plane is going to be displaying the reflections of our artwork. And that's why I'm calling it mirror, because it's basically a mirror. So for the texture width, let's just set that to the inner width of our window. And for the texture, let's see, I forgot a comma here. For the texture height, we'll do window inner height. And then let's go ahead and add that to the scene. And right away, you can see that we don't really see anything. And it's because the default orientation of the reflection plane is not where we want it to be. So we have to rotate that plane so that it's sitting where the surface of the mirror is basically pointing upwards. So we can fix that by rotating the mirror. So we'll do rotate X, and then we have to rotate it by 90 degrees. And 90 degrees in radian world is math.pi divided by 2. So we still don't see anything yet because the reflection plane is basically sitting right at our eye level. So we need to drop it down in the y-axis a little bit. So do mirror position y equals, let's do minus 1.5. Let's try that. And there we go. We can now see we have the reflections sitting quite a bit below our artwork. I think that's a bit too far, so I'm going to tweak that to try 1.1. And that's a little bit closer. I think that makes a bit more sense for a reflection. So you can imagine that the artwork is just barely sitting off the ground or sitting on the ground. But the reflections are a little intense, I think. So that indicates an extremely reflective surface. Now, if we imagine this in some gallery, so there's like a polished black floor, we wouldn't get quite the strong reflection. So we can attenuate that reflection by setting the color. So if we set this to white, we're going to get the full strength of the reflection. So we can reduce the intensity by setting it to a shade of gray. So let's do kind of in the middle here for gray. That's still pretty bright. Not really liking that. Let's make it a little bit darker. Let's try a 5.0. And there, that is a little bit darker. It's looking a little bit better. Let's try going even lower to like 3.0. And there, we get nice subtle reflection there. I think that looks pretty good. So to summarize, creating a reflector is pretty simple. We just have to specify the geometry of that reflection plane. And we need to make sure that we're rotating that circle so that the face of it is pointing upwards so we can actually see it. Then we're dropping that circle down a bit so that it's sort of sitting right below our artwork. Then we're setting the width and the height of that texture to the size of the window. Now, our window width and height may change, so it's also a good idea down here when we're updating our renderer and our camera. We'll also update our mirror as well. So how we can do that is do mirror get render target. That's basically the surface that we're painting to. And then we'll do set size. And then we'll do window inner width, window inner height. And I don't think we'll be able to see any change in effect here, but you know, it's just good to be thorough doing this kind of thing. So visually, our gallery is looking really good, but we don't want it to just continuously rotate. We want the user to be able to kind of focus on a piece of artwork and then click an arrow and rotate to the next one. And you can also imagine that these could be links to projects in your portfolio if you wanted to adapt this project. So before we get to the user interaction bit where we're implementing clickable buttons, we need to actually add those buttons, and those are going to be those left and right arrows I was talking about. So I'm going to remove this rotation. We're not going to need that anymore. And then back on our for loop, we need to add those left and right arrows on either side of our artwork. So right after we create the artwork, I'm going to create a new mesh called left. And for the geometry, I'm just going to do a really small box. So I'm going to make the width something smaller, like 0.3. The height will be the same. The depth will be 0.1. And then for the material, let's do a standard material, so it'll be lit. And for the map, I want to use these left and right arrows that I have here. So I'm going to go ahead outside the for loop. I'm going to load those textures using the same procedure that we used for the artwork. So we'll say left arrow texture and right arrow texture. And then you just pass in the names of these with the extension left PNG and right PNG. Now down back where we're defining our arrow mesh here for the map, I'm going to pass in the left arrow texture. And then I want this to sit right next to my artwork. So we'll do left position. So I'm going to use the set method here. But I think I need to set this to like 1.5. And then the Y is going to be 0, and the Z is going to be same Z position that we had for the artwork. And we'll add this to the base node. So it looks like things are mirrored a little bit. So I need to set that to the other side, which means we need to do minus 1.5. And it looked like it needed to go a bit further as well. So let's try 1.8. So you can see we have that cube sitting right there, but we're not seeing our arrow. Why is that? And that's because our arrow texture has some transparency on it. And by default, when we're specifying a texture, it's not going to use transparency. So on our mesh standard material, right after the map, let's set the transparent property to true, and we will save that. And there we have our left arrow. Now I think I need to squash the depth a bit more here. We're getting the texture on all sides, which kind of happens by default. We could also use just a plain geometry, which doesn't have 6 sides, just that one side, but I've had better luck using box geometry for things. So let's set this to 0.1 in the Z direction, and then that fixes that issue. Now we also need to add this arrow to the right side, so we can just copy. Let's see, I want to rename this to left arrow. Make it a bit more verbose. And then below here, we'll add the right arrow. Same geometry. We need to use the right arrow texture. And we need to go on the other side of the image. Make sure we're adding the right arrow mesh, not the left arrow. And looks like I accidentally, I forgot to change this variable here. So no more left anywhere. All right. Okay, there we go. We have our left and right buttons But when I click on these, they don't do anything, and that's because we haven't hooked up any user interaction. We don't have any user input. So that's going to be our next step, is determining when we're clicking on these arrows and what do we do once we click on them. So first, let's work out the issue of detecting clicks on the arrows, and then we'll work out what to do after the click has been detected. We're talking about user interaction, we're talking about clicking, and that means we need to add another event listener at the bottom of our file. So do window, add event listener. We'll listen to the click event. And just for the sake of brevity, I'm not going to handle left or right or middle mouse button clicks. A mouse button click is a click. So how do we take where we're clicking on the screen and convert that into 3D? Because what I'm looking at, the monitor, is 2D, but I'm looking at a 3D scene, so how do we do that conversion? And luckily, there is already something that can help us out with that, and that's called a Raycaster. So I'm going to go ahead and instantiate a new 3 Raycaster. So basically what a Raycaster does is we can give it a set of mouse coordinates that we clicked on the screen, where the user clicked, and we'll give it the camera so we know from what perspective the user is looking at that 3D scene. And it's going to shoot a ray into that scene, and it's going to tell you what objects intersect that ray. So how we do that is we do Raycaster set from camera. Now we need to pass in a set of mouse coordinates here, but these are in normalized device coordinates, so between -1 and 1. So we've got to do a little bit of math to convert our mouse click event coordinates to these NDC coordinates. So I'll leave that as a TBD. Let's just create a variable really quickly. Let's see, this is a 3 vector 2, which is a set of x and y coordinates. So we'll say mouse NDC is equal to new 3 vector 2. We'll fill that in later. And then we need to pass in our camera, which is the same camera that we've been using. Now, coming back to this a bit later, so we're basically telling our Raycaster where to cast that ray, and then we need to tell it which objects to try to intersect with. So on our Raycaster, in order to actually cast the ray, we call intersect object or intersect objects. We can do intersect object in this case, and I'm going to pass in our root object, our root node, because all of the artwork is a child of that root node. And we want to set the recursive parameter to true so that it tries intersecting that ray with all the different pieces of artwork. It's going to basically go through that whole scene hierarchy of parents and all the children, and it's going to check against everything. If you only want to check against one specific object, then you would set that to false. Or if you have an array of objects, then you would do intersect objects and then pass in an array of the objects you want to intersect with. But we're going to do the root node, do it recursively. So this returns an array of intersections, and they are sorted by distance closest first. So we'll set this to a variable called intersections. So if intersections.length is greater than 0, that means we know we clicked on something. So let's just log intersections to the console at that point. All right, now we need to go back to this mouse NDC, and we need to figure out how to calculate this. So the mouse click event, we need to pass that event in as an argument. And for the x coordinate, what we can do is we want to take the client x of that mouse event. So if you remember, we set our size of our canvas to the size of the inner width and height of our window. So we'll divide by window inner width. Now client x ranges from 0 to inner width. So you can think of, both extremes of that. If client x is 0, we divide by number, that gives us 0. And if the client x is all the way to the other side of the window, and we divide by the width of the window, that'll give us 1. But we need this to be between -1 and 1, not 0 and 1. So we can easily fix that by multiplying this by 2. So it'll range between 0 and 2, and then we'll subtract 1, and that'll range between -1 and 1. And then we do the same thing for the y coordinate. But the only difference is that, of course, we're dealing with the height of the window here, but the y-coordinate is inverted. So what Three.js thinks is up, the mouse client Y thinks is down, so we got to negate this. So that's a negative sign there. And then propagating that forward, we need to add 1 instead of subtract 1. So I know that's a little bit of a tricky algebra, but this is basically a formula. You learn it once, and then you just copy it over every time you're doing raycasting. So now that we've converted our mouse coordinates into normalized device coordinates, we can go and try and click on some stuff. So let's get the console pulled up here. And if I click on some artwork, you can see we get a result of 2 things here. So it's really hard to tell what things are without any names. So I think we should add some names first before we go any further. So let's go back into our for loop. And what we can do is do artwork name is equal to art. And then we're just going to put the index in here. And same for the border. So underscore in as well. And then the left arrow, we'll call left arrow. And then right arrow. Let's see, I need to fix these names as well. Right arrow, right arrow. This one should be left arrow. This one should be border. Apologies for that. All right, so now I click on this, and we can open these up, and we need to go down into the object property here. So these objects that are being returned are intersection objects. So there's a whole bunch of information here. You can get the point that you clicked on, the UV coordinates, a whole bunch of stuff we don't need to worry about right now. But what we're concerned about is the object that we clicked on. So we can see for this first intersection, we clicked on the first piece of artwork, art_0. And if you look at the other result, that is the border. So the ray, even after it hits something, it's going to keep on going and intersect with all the other objects in the scene that we passed in. Now, if I click on the left arrow, we just get one result. You can see we get left arrow 0. And then if I click on the right arrow, we get right arrow 0. So when we're clicking on things, we need to basically determine when we're clicking on a left arrow and when we're clicking on a right arrow. Those are the 2 different actions that we have. We need to rotate in the correct direction based on what arrow we clicked on. So to simplify our logic a bit, I'm actually just going to name this left arrow. I'm going to get rid of the index. And down here, I can do something like this. So I'll say if intersections, and we're just going to take the first intersection, because we know there's at least one. Do object name is equal to left arrow. Then we'll do console.log clicked on left arrow. And we'll do the same thing for the right arrow. So going back in here, now I click on the artwork. Nothing is happening, of course, because they're not named left or right arrow. But if I click on the left arrow, we get that message. Click on the right arrow, I get that message. So now we need to rotate our gallery based on which arrow we click on. So let's go ahead and create a function called rotate gallery. And I'm just going to throw that up here for no good reason. So we'll have some additional arguments that we're going to pass in here, but for now, let's just leave that. So instead of these console logs, we're going to call rotate gallery. And then I want to use the same function for both. So I need to be able to rotate in both directions. So let's add a direction property to our gallery. And that's just going to be a number. It's going to be 1 or -1. So if we're rotating to the left, we'll do -1. If we're rotating to the right, then we'll do 1. So rotate gallery is going to be a really simple function, similar to what we were doing in our animate function before. All we have to do is to either add or subtract 60 degrees from the Y rotation of our root node. So we'll do rotate Y, and then we're going to do direction times, then we're going to do that angle again, 2 times math.pi divided by count. So this is going to rotate that root node either 60 degrees to the left or to the right. So let's make sure we got everything correct here. So left is negative, right is positive. And I think I picked the right signs for those. We'll find out. So if I click on this left button here, you can see that we go to Starry Night, and then the wave, and then I don't know the names of these other ones. Sorry about that. So that looks like that's working. Now I click on the right arrow, and then it goes in the other direction. And let's just do a couple rotations around. So that is all working as expected. Now this looks really good, but it'd look a lot better if it was animated. So instead of just jumping to the next photo, what if we kind of eased in, did like a smooth rotation from one piece of artwork to the next? That's really what sets, great Three.js apps and projects above the just good Three.js apps and projects, is the additional effects, the smooth camera animations, things like that. So let's make this look great instead of just good. Now, unfortunately, I had some audio issues, so I'm having to re-record this part of the video. So I apologize for any discontinuity, but let's pick up right where we left off. And that was with adding some silky smooth camera animations to our gallery. So let's go back to our code here. And in order to do these animations, we're going to need another library, and that library is called Tween. Now that library used to come packaged with Three.js, but as of version 151, I believe, it no longer is, so we need to install that separately. So pull up your console and open a new terminal, and all we need to do is npm i tween. Then if we go and check our package.json, you can see it installed version 0.9. Now in order to use Tween, we need to obviously import it. So I'm going to import Tween from Tween. And then let's go down to our rotate gallery function. Now we're going to eliminate this. We don't need this rotate Y function anymore. We're going to be replacing that. But we will keep the angle calculation, and I'm going to call that delta Y, because that's the change in the Y angle. And then to create our tween animation, we'll do new tween. And we pass in an object here. So we pass in an object, and then we're going to specify the property on the object that we want to animate. So the object in this case is the root node rotation. Then we want to move that to, then we'll pass in an object here of the properties that we want to animate. So we're animating the Y property. So we want to move it from its current value to a new value. So we'll take the current rotation, the current Y rotation of the root node, and then we'll add on delta Y. Now next we need to tell Tween how to animate it. So do we want to start off rotating it really fast and then end slow, or vice versa? So we can control that using easing. So you can notice that we're just continually chaining these different functions together, and that's one really nice thing about Tween. Makes it very easy to work with. So for the easing, we need to import this as well, so that should auto import. You can see it's added in here. And there's a lot of different easings to choose from. So we'll play around with a couple of these, but kind of the standard one is the quadratic in and out. So that gets a really smooth animation at the beginning and the end of the animation. And then all we need to do is call start. Now, if we go into our app and I click on these buttons, you can see nothing's really happening. Now, we know our buttons work. We've tested those. So the one thing that's missing here is each frame that we're rendering, we need to tell Tween to update any current animations it has. So there is an update function that comes with Tween. So you can see it's right here. But this is a bit ambiguous of a name, so I'm going to give it an alias. I'm going to call it Update Tween. And going back down to animate here, all we need to do is call Update Tween. We don't need to pass in the time. And then now if you go back, you can see we get these really nice animations. So our animation is now working as expected. Now just for fun, let's try out some different easings here. So we've done the quadratic. So let's try bounce. That sounds fun. So that is a little bit intense. Let's just do it on the out here. So you can see when it lands on that final image, it bounces a bit. I think this is more suitable for when you're translating things back and forth. Maybe you have something dropping down, it's bouncing on the ground. Applying this to an angle is just a bit too harsh. So let's just stick with quadratic. We know that gives us really good results. And be sure to set this to in out. So it applies to both the beginning and the end of the animation. So the final thing that we're missing is the titles and the artists on our images. So you can add 3D text with Three.js, but I'm going to be using actual HTML element that we're going to overlay on our canvas. So I went ahead and added two HTML elements, a level 1 heading for the title and a level 2 heading for the artist name. Now this isn't a tutorial on HTML and CSS, so I'm not going to get into the how and why of what I did here, but I will do a quick overview of these styles that I've added and how we're going to use those to fade the text in and out. And you can see I've also imported a font here. So for the heading 1 and heading 2, I'm using the Inter font, and I got this from Google Fonts. Now Google Fonts is great if you want to add some more professional looking fonts to your site, and since Three.js is more of a creative tool in most cases, you definitely want to use some more professional, nicer fonts. You just don't want to use the built-in fonts in the browser. So I searched for Inter because I already knew that was the font I wanted. And you can see you can play around with the different weights and styles here. But when you're ready to download the font, you just click the Get Font button in the upper right there, and then you get the embed code. So you can pick all the different weights and styles that you want. I just want the Roman font, so that's just the normal non-italicized version. And I just wanted the thin weight. So rather than importing all these different weights, I'm just importing one weight. And then you can copy this code here and embed that in the head section of your HTML document. So highly recommend using Google Fonts. There's a lot of other font providers out there, but it's nice to have these fonts embedded right in the header of your HTML. So let's look at a few other CSS styles that we have here. So obviously I'm setting the color to white. I'm center lining the text. I'll talk about this one in just a bit here. For the headings themselves, I'm just using fixed positioning. Probably not the best way of doing it. If you're actually doing an app, you want the text to kind of flow with the document, but just for this demo, this is going to be fine enough. We want our headings to fade in and out slowly when we're moving back and forth. So let's go look at our app once more. So when I click a button, I want to fade the text out. And then when I land on the new image, I want to fade the new title and artist back in. I don't want to abruptly change the title and the artist. It just looks a bit jarring, doesn't look professional. So in order to do that, I set a transition on the opacity of our heading 1 and heading 2 elements. So just like we did with the tween animations, we're using an in and out easing. I'm guessing this is probably quadratic, I'm not sure. And we're transitioning that over 500 milliseconds. So that'll give us a nice fade in and out. Now we actually need to set the title and artist. Right now those are just blank. So let's go back into our JavaScript file, and at the very bottom here, we're going to initialize those. So do document, get element by ID, title, and we'll set the inner text to the first element in our titles array. And then we're going to do the same thing for the artist. That will be artists. So now we can see we have our title of our artwork as well as the artist here. But of course, when I go back and forth, it doesn't change that. We don't have the code for that yet. So before we get to actually changing the text of our title and artist, I'd like to show you how we are going to fade our title in and out. So that's actually going to be part of our tween animation. So right after we call start, you can see there are 3 different functions here on complete, on start, and on update. So obviously on start gets called right after we start the animation, on complete gets called after we finish the animation, and on update gets called each frame of the animation. So for on start, this takes a callback, and this is the code that we want to execute right after this is called. What I would like to do, I'm going to copy these here. So I want to fade out my title and artist. So I'm going to set the style and the opacity, I'm going to set that to 0. And then our CSS transition here on the opacity is automatically going to handle the fading in and out of that opacity. So let's see what that looks like. So you can see that fades out nice, but obviously it doesn't fade back in because we haven't set the opacity back to 1 anywhere. So after this, we'll call on complete, which gets called after the animation finishes, and we'll set the opacity back to 1. So now if I click that, it fades out and then fades back in. And we'll keep doing that as we rotate to each piece of new artwork. Now let's go ahead and change our titles to be matching the artwork. So remember, earlier on in the video, we added these arrays of the titles and the artists. So when we're going back and forth between each piece of artwork, we need to know which piece of artwork we're currently on and which one we're going to, so we know which index in the array that we need to pull. Now right now we don't really have that information. All we know is that we've clicked on the left button or we clicked on the right button. So there's actually a really cool way that we can embed the index of the artwork into those buttons, and that's using a property called user data, and that is a property of the 3 mesh. Now right after I set the name here, I'm going to do left arrow user data. So if you look at the documentation, we can see that this is an object that can be used to store custom data about this object 3D. So it's just a generic JavaScript object. You can put whatever you want into it. You can actually put in primitive values as well. So I'm just going to set this to I, which is the index of the current artwork. Now what we could do if we want to save ourselves some work later on is, instead of storing the current index here, we would store the index to the left of our painting, and in the case of the right arrow, we can store the index to the right of the current painting. So yeah, I think let's do that. That makes sense. And then we don't have to do the calculation later on. So for the left arrow, I believe we need to do I plus 1. And then we need to make sure that this doesn't overflow. So if it gets to be, equal to count or greater, then we need to go back down to 0. So let's make sure we handle that as well. So if I is equal to count minus 1, then we want to set this to 0. Otherwise, we're going to do I plus 1. And that'll make sure that'll wrap back around to 0. And now it's the same for the right as well, except we're going in the opposite direction. So we're subtracting 1. So if I is equal to 0, and we subtract 1 from 0, we want to set this to count minus 1. Otherwise, we'll just subtract 1 from I. So now our left and right arrows contain the next index that we need to move to in the user data. So let's go back down to where we're doing our raycasting. So let's get the object out of our intersection here. So I'm just going to call it obj. So this will be intersection 0 object. We can actually replace these as well. And then our new index is going to be obj user data. And let's pass that new index into our rotate gallery function. So going back up to rotate gallery, let's add a new parameter called new index. And then when we complete our animation, we want to update those titles. So I'm going to copy these lines down here again. And we're going to set these. So since the opacity is animated, these titles and artists are going to get updated immediately, so we're not going to see that change in the title and artist. So let's set these to new index rather than 0. And now let's see if I got my directions right. So I know Starry Night is on the left here, so if I click on the left arrow, the text faded out and faded back in, and we now have the correct title. To make sure that we're handling the indices correctly, so it looks like that's working. And now let's go in the other direction. And it looks like that's working as well. So there we have it. That is our finished art gallery. We have some beautiful animations. We have some nice reflections. We have some nice text fading in and out. This was a really great project for learning the fundamentals of Three.js. You've learned about geometry, materials, meshes, how to handle user interaction, adding lights to your scene, a whole bunch of different things that will apply to your future Three.js projects. And this is a really good project that you can incorporate into your portfolio as well if you're looking for a job. This will really make you stand out, and you can replace this artwork with maybe images of your projects. And when a user would click on that image, it may take them to a page in your portfolio that'll share more information about your project. So lots of different ways you can take this project and adapt it to work for you. So thank you so much for joining me in this coding adventure, and until next time, happy coding.